Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we are discussing the chapter Transaction Management. In Transaction Management, today we are going to discuss about Concurrency Control. So let us start the session. Granularity of data are the levels of data which we can view. Transaction Management. Sorry, sir. Yeah. So the granularity of the data. The first one is field or attribute. The second one is record. And the next one is block or page. And the last one is relation. What is meant by this granularity of the data? Suppose we have a relation student. We have a relation student. Let us suppose it is having some 1000 records. Let us assume it. We are having 1000 records. Now the entire relation I need to store in the database. In hard disk, everything will be represented in terms of the pages. So let us assume per page you can write only 100 records. Per page we can write 100 records. Then how many number of pages we need, sir, to store this relation? We need 10 pages. So the relation is page 1, page 2, the last one is page 10. In a page or within a page, this is my page, sir. Here, this is my first record, this is my second record, and this is my last record. Am I clear, sir? Now, in a record, that is, this is my record 1. In a record, I may have so many fields like ID, name, age. So this is the levels of data which we can view in the database, right? Now suppose some user is accessing the first page. Now the question is, do you have any problem if another user is accessing some third page? No, right? Because the first person is working on page 1 and the second person is working on page 3. So we will not have any conflict or any problem if two different persons are working on two different pages. Am I clear, sir? Now let us assume within a page, the first candidate or the first person is working on record 1 and the second candidate is working on record 15. Do you have any problem, sir? No, right? In first line he is working and in 50th line he is working. So then also we don't have any problem. Am I clear, sir? The last one, within a record, some candidate is working on the first attribute and some candidate is working on the last attribute. So we are having concurrency access to the table relation student. So that is, the first one is at page level. When one person is accessing one page, the second person may access the second page. That is page level concurrency. Instead of that one, the next one, record level concurrency. When one person is working on record 1, the second person may work on another record. And the last one is attribute level. Within a same record, when one person is working on the first attribute, the second person may work on the last attribute. Okay. So this is the levels of concurrency execution on the database. Okay. In the database, concurrency control is up to record level. Up to record level. When one candidate is working on one record, suppose he is working on record 1, then the second person no need to wait when he want to access the 12th record. Suppose he want to access the same record R1, then he need to wait. We don't have any choice. Suppose he is working on some different record, then no need to wait. He can access that record at the same time. Concurrency control. What is concurrency? As I told, 2 or more transactions or 2 or more users executing the same database, same relation simultaneously. So 2 or more transactions are executing the same database simultaneously. Now let us have the small question. Which level of locking provides the highest degree of concurrency in a relation database? Page, table, row. Okay, the first one is table. When one candidate is working on student table, the second candidate may work on employee table. That is table level. When coming to page level, as I told you, within the same relation, suppose the relation is student. Within the same relation student, the first candidate is working on page 1 and the second candidate is working on page 100. Then no issue. Then row. Instead of row, you can call that as record. Within same page, suppose he is working on student and both are accessing the same page 10, but one fellow is accessing record 1, another fellow is accessing record 12. Okay, now which will provide the highest degree of concurrence? Highest degree of concurrence. The question is, what is degree of concurrence? What is degree of concurrency? Maximum number of users allowed. Maximum number of users allowed to access the database at the same time. At the same time. Suppose 100 users are working on the first table student on 100 different pages and some different records. Let us assume there are some 50 users who wants to work on employee table and all they wants to access on different pages and different records of the employee. If I have only the first level of concurrency, then at the same time I can allow only 2 users. One is for student table, one is for employee table. Am I right, sir? So at the same time, how many users you are able to allow, sir? Only 2 users. Now suppose we are allowing at page level. We are allowing at page level. Suppose 100 users are working on different pages. Let us assume something like some 50 users are working on page 10 and the remaining 50 users are working on page 20. Let us assume the same. Some 20 users are working on page 3 and some 30 users are working on page 10. Let us assume it, sir. Now, if I allow at page level, what will happen, sir? Any one of these 50 users can be allowed to access student table. Similarly, any one of the remaining 50 users also can be allowed at the same time because both people are working on different pages, right? And coming to employee table, any one of these 20 can be allowed and any one of these 30 can be allowed. So totally how many users you are allowed, sir? 4 users, right? Now, let us assume these 50 users are working on 50 records. These 50 people are working on 50 records in same page 10. If you allow at record level, all the 50 users can be allowed at the same time. Similarly, if the remaining 50 users are accessing different records, all the remaining 50 also can be allowed. In the same way, I can allow the 20 users and the 30 users. If each and every candidate, instead of candidate, we can say user, or we can say simply transaction. If every transaction is working on different record, maybe within the same page, maybe within the same table, all the users can be allowed. So at the same time, how many users you are allowing, sir? You are allowing approximately 150 users. Right, sir? So, which is providing highest degree of concurrence, sir? Row level or record level is providing highest degree of the concurrence. Hope you understood it. If you have any doubts, please raise in chat box, sir. Now, let us define what is a schedule. A schedule represents the order of the transactions are executed. A schedule represents in which the operations of the transactions are executed. Suppose I have the first transaction which wants to transfer from account X to account Y 100 rupees, and I have second transaction which will add some 1000 rupees to the account X. Okay, this is the story. Now, what is the order of the operations? Not order of transactions, sir. Order of the operations. When coming to the first transaction, what can be the operation, sir? First, I want to read the value of X. That is my first operation. Then I want to update, that is I want to subtract 100 rupees from X. I want to update back the value of X to the database. Then I want to read the value of Y. We need to update the value of Y. That value I need to store back to the database. This is the sequence of operations in the transaction. Please note that within a transaction, this order cannot be changed, because first I need to read the value of X, then only I can modify the value. After modification, I need to update the database. So within a transaction, this is the main important note, sir. Within a transaction, order of operations cannot be changed. Right? What about the second transaction, sir? First, I want to read RX. Then I want to add some 1000 rupees. That means I am doing the modification to the variable X. Then I want to update back. Okay. Now, to have more clarity or more distinction, instead of writing 11, let me write 11, 12, 13. Okay. There is no meaning for these numbers, sir. My intention is only to differentiate the operations of first transaction and second transaction. Right. Now, totally how many operations we are having, sir? 9 operations. 6 from first transaction, 3 from second transaction. Am I right, sir? Now, listen to me. I can execute all the 6 operations of the first transaction, then followed by the 3 operations of the second transaction. This is one way of planning. Instead of this one, I can execute the operations of the second transaction first, followed by this one. These two are very clear, sir. I'm sorry. So these are examples of schedule. Assume this is S1, this is S2. These two are the examples of serial schedules. What is meant by serial schedule, sir? If I don't complete the first transaction, or if I don't complete any transaction, I don't enter into second transaction. So here please observe it. Until I complete all the 6 operations, until I complete all the 6 operations, I am not starting the second transaction. So transaction 1 followed by transaction 2. Instead of that one, I can do first the transaction 2, then the first transaction, right? Instead of these two schedules, I can have one more schedule. Like I completed 3 transactions for the first transaction, then I taken 2 transactions from second one. Again, I complete the next 3 operations of first schedule, then the last transaction of the second transaction. Am I clear, sir? Here, both the transactions are executing simultaneously. Please observe it. The operations of the transactions are started simultaneously. Even one transaction is not completed, I am starting the another transaction. This is the example of concurrency schedule or concurrent schedule. So concurrent schedule means even we don't complete a transaction, you can start another transaction. Now one small question is, can I have a schedule like this? Can I have a schedule like this? Please observe it, sir. 1, 2, 3 first transaction, 11, 12 second transaction. I'm sorry, sir. Now please observe these two. Actually, they should be executed in the order of 4, 5, but the order was changed within a transaction. Order was changed within a transaction. That is not allowed, sir. So within a transaction, the order of operations cannot be changed. So this is not allowed. Hope you understood it. So it is the sequence of the operations in which we are executing all the given transactions. Not only 2 transactions. Sometimes we may have 3 transactions, even 10 transactions also. Okay. Suppose I have only 1 transaction. There is no issue or there is no order. Simply I need to execute all the operations one by one. That's it. What are the possible schedules? Like I given in the previous slide, we can have so many possible schedules. Not only 3, sir. 2 transactions can be executed in so many different ways. Then what are the total number of possible schedules? Okay. So for that, I need to know the number of transactions. Let us assume I have 2 transactions. Then within first transaction, how many operations are there? Suppose T1 is having only 2 operations, A1, B1. So these are the 2 operations. Similarly, T2 is having 2 operations, A2, B2. This is also 2. Then how many possible schedules are possible? Right? So let me give it, sir. Simply I can execute the first transaction operations. So all the operations of the first transaction, then followed by all the operations of the second transaction. This is one example of a serial schedule. Serial in the sense transaction will start once we complete another transaction. Okay. So this is one example of a schedule. Instead of this one, I can have 2 operations from the second transaction, followed by 2 operations from the first schedule. Now let me write the concurrent schedules. So look at this. A1 I started. Now before I do B1, I can have A2. Then I can have B2. Similarly, I started with A1 and in between those two, I can write these two. Instead of this one, I can start with second transaction and I can have like this. And what is another possibility, sir? A2, B2, A1, B1. Suppose I started with A1 and I written B2, A2, B1. Can I have the last schedule, sir? No, sir. This is not allowed. So this schedule is not allowed. So whenever I have 2 transactions and the number of operations in first one is 2 and number of operations in second one is 2. These are the possible schedules of 2 transactions. Hope you understood it. Now the question is there a way to count? Since I have only 2 operations and 2 transactions, I can list out all the possible schedules one by one. Suppose I have 10 transactions. Within a transaction, I have so many number of operations. It may not be possible or it may not be feasible to list out all the schedules. Now the question is there a way to count all such number of possible schedules? That is the first problem we are going to discuss. Right? So before going to that, first let me explain the types of schedule. These types of schedules we have already seen. Let me explain. Coming to the first one, serial schedule. What is serial schedule, sir? If I don't complete the operations of the first transaction, I don't start the second transaction. Okay? So either it may be T1 followed by T2 or it may be T2 followed by T1. This is only whenever I have 2 transactions. Suppose I am having 3 transactions. Sorry, sir. Let us assume I am having 3 transactions. Then I can write T1, T2, T3. Instead of that one, T1, T3, T2. Sir, what is meant by T1, sir? It is not a single operation. It is the entire sequence of operations in T1. Similarly, you can have T2, T1, T3. Like that, we can write so many, sir. All these are serials because we are not starting a transaction before we complete another transaction. Instead of that one, we can have non-serial schedules. That is concurrent schedules. So as I explained, before I complete a transaction, I can start another one. Okay. Suppose I completed 2 operations of the first transaction. Then I will start second one. Then I will switch to first one. I will do one more 2 operations. Again, I will switch to second transaction. I will do some operations. Like that, I will switch between the transactions. That is non-serial schedule or concurrent schedule. And we are having 3 more types, sir. To discuss these schedules, we need some more details. Okay. What are those? Recoverable schedule, cascadeless schedule, and strict schedule. So these are the 5 different types of schedules we are going to discuss. So the first 2 we have already discussed and we have seen some examples on these 2. The remaining we will discuss in this session. Coming to serial schedule. What is serial schedule, sir? As I told you, if I don't complete first transaction, I cannot start the second transaction. Let us consider the same thing. After completion of 2 operations in first transaction, then only I can start the second transaction. This is one example of a serial schedule. Okay. This is one example of a serial schedule. Now the question is, there may be more than one serial schedule. The first result is there may be more than one serial schedule. For example, consider the same one. This is my schedule 1. Instead of that one, I can have T2 followed by T1. What is meant by it, sir? I will complete the operations of T2, then followed by operations of T1. This is another serial schedule. Now the question is, how many you can have? How many you can have? The number of serial schedules. The number of serial schedules. Okay. For that, whenever you have 2, what you can do, sir? You can do either T1 followed by T2 or T2 followed by T1. Whenever you are having 3, I can write T1, T2, T3. T1, T3, T2. Or you can start with T2, then T1, T3. Or we can start with T3, T1, T2. T3, T2, T1. What is this list, sir? This is the list of arrangements of 3 numbers. Am I right, sir? So how many you are having? Total is 6. That is equal to 3 factorial. Here it is 2, which is equal to 2 factorial. Similarly, whenever I have n number of transactions, it will be n factorial. What is n, sir? Where n is the number of transactions. N is the number of transactions. Am I clear in this, sir? That is about the number of serial schedules. Now let us go for the next one, non-serial schedules. Coming to non-serial schedules, as I explained, I will do one operation from first transaction. Okay, let me write it like this. I will do the first operation from first transaction. Then I will switch to second transaction. I will do the first operation of the second transaction. Again, I will switch to first transaction. I will do one operation on first transaction. Again, we can switch to the second transaction and I can do the next operation. Like that, you can do. So here both transactions were started or both transactions are running parallelly. So you can say, what you can say, sir? Multiple transactions started simultaneously. Instead of saying started, if I use the word running, it will be more nice. It will be more nice, sir, because we don't start all the transactions at the same second of time, sir. Okay, but the operations will be run at the same time from multiple transactions. Okay, multiple transactions started simultaneously. Now the question is, like we counted the number of serial schedules, can I count the number of non-serial schedules? Yes, of course, we can do it. To count the number of non-serial schedules, I need to know the number of operations in T1 and I need to know the number of operations in T2. Okay, so before going to that counting, let us finish the types of schedules. Recoverable schedule. What is a recoverable schedule? Suppose T1 reads a value and writes a value. T1 reads a value, writes a value. Then T2 reads the particular value of X and it is doing some modification like that. Now the question is, this x value, that means T2 reads a value which is modified by T1. T2 reads a value which is modified by T1. So the T1 answer is depending on, T2 answer is depending on T1. So I can say simply T2 depends on T1. In such case, T1 should commit first. T1 should commit first. Then T2. Then T2 should commit. That means what, sir? After so many number of operations, I may have T1 commit. That means T1 completed. Then I may have some other operations. Again, T2 is committed. But which transaction committed first, sir? T1 is committed first because T2 is depending on T1. That is the meaning of it. Instead of this one, suppose I have T2 commit first. Then after some time, T1 committed. Okay. Now this is not recoverable, sir. The second one is not recoverable. Why not recoverable, sir? Suppose this T1 done some wrong. T1 done some wrong X. Okay. And T2 get that value. T2 read that value and done it and committed. So that means T2 cannot be rolled back or T2 cannot be redone or undone anything. So T2 was done. Again, then T1 realized that it is wrong. So whenever T1 realized, it will be restart, or you can say abort. Then it will work with correct value of X. But what about T2, sir? He already taken wrong input and he done and he saved it. That means the mistake of T2 cannot be corrected. The mistake of T2 cannot be corrected. Am I clear, sir? So that's why it is called non-recoverable. Instead of that one, suppose if it is committing, whenever T2 realizes there is a mistake, whenever he realizes, so he will do some correct entry. Then T2 also will realize the entry is not correct. Then he will also restart. But here T2 already given. Okay. Something like, let me give one best example. Suppose I have two students. Suppose I have two students. Assume T1 copied from T2. So student 1 copied from student 2. Now suppose student 1 returned the answer sheet. Student 1 returned. Now student 2 realized he done some wrong. Then he corrected. So student 2 is happy. What about student 1, sir? He executed the program or he executed the transaction with wrong entries and he submitted. So his mistake cannot be recovered. That is the meaning of recoverable schedule. Hope you understood it. Cascading abort schedule. What is cascading abort schedule? Something like, suppose T1 is having the values, this one. Then T2 is reading the value of X. Let us assume I have T3. He also doing this one. That means T3 depends on T2. T2 depends on T1. After some time, T1 realized some mistake. T1 realized some mistake. Then we will restart T1. Whenever you restart T1, what will happen, sir? This fellow T2 is depending on T1 and he will observe T1 is restarting. So there might be some mistake. So he will also restart. So whenever you are restarting it, since this fellow is depending on T1, he need to restart. When he will restart, he will also restart. Am I right, sir? The same student example you can take, sir. Student 1, student 2, student 3. Suppose student 2 copied from student 1. Student 3 copied from student 2. Now, after some time he realized and strike out the problem or strike out the page. Then automatically what this fellow will do, sir? He will also strike out. Then he will also strike out. That is cascading abort schedule. In this example, I have 3 transactions. Let us assume T2 is depending on T1, T3 is depending on T2. Like that, almost there are some 100 transactions. Everyone is depending on this one. So after some time, T1 done a mistake. Then he need to restart. No issue. Okay. But because of the mistake in T1, all the 100 transactions need to be restart. So instead of restart, let us use the technical term rollback. So since there is a mistake or there is some failure in T1, it need to be rolled back. Since T1 is rolled back and all the remaining are depending by successively, so all they need to be rolled back. That is called cascading rollbacks. Cascading rollbacks, or you can say cascading abort schedule. Hope you understood it, right? Now the question is, why you have this problem, sir? Since student 2 eagerly started copying, instead of that one, suppose he waited till student 1 says yes, everything is fine, then student 2 can do R only. Suppose student 3 is waiting till student 2 says everything is fine. Everything is fine means what, sir? He will make a tick mark commit. Then no issue. That is cascadeless schedule. That means T1 reads, writes, then T2 don't start. Okay. T1 should commit. That means he need to make a tick mark. Then my T2 will start. Because now he got a clarity or he got a confirmation from T1. He done correctly. Then T3 don't start, sir, till T2 commits. Then he will start. So there is no concept of rollbacks because he got the confirmation that everything was correct in T1. Since everything was correct in T1, it don't roll back or it don't restart. Since T1 don't roll back, T2 also don't roll back. Clear, sir? So for that, what is the simple story, sir? When, let us assume some 2 transactions. If T1 reads a value modified by T2, then T1 should not start till T2 commits. So then T1 reads it. When he will start or read, sir? Only after T2 commits. Only after T2 commits. So this is the way we need to verify whether it is a cascadeless schedule or not. Hope you understood it. The last one, strict. He is very strict schedule, sir. So either it reads or write. It don't start until he don't get any confirmation from another one. So if T1 reads or writes a value, anything, any operation, which is modified by T2. 1 minute, sir. Yeah, which is modified by T2. Then either it is read operation or write operation. T2 should commit first. After that, T1, that is T1 is depending, right? After that, T1 start read or write. That is strict schedule. So these are the types of schedules we are having in transactions. Now the number of schedules. What is the total number of possible schedules? That may be a serial schedule, that may be a concurrent schedule. Suppose we have two transactions. Assume I have n1 number of operations and assume I have n2 number of operations. For easy explanation, let us have 10 operations in first, some 6 in second. Okay. Then the question is, in a schedule, how many lines you will have, sir? 1, 2, 3, so on up to 10, then followed by 1, 2, 3, so on 6. The second operations, right? So totally 16 operations. Right, sir? So totally 16 slots. Out of 16 slots, we need 10 slots for first one. That may be anywhere, sir. We need 10 slots for T1. So what I do, sir? 16 C 10. Then in those 10 lines, I will write 10 operations. Then how many remaining slots you have, sir? 6. In those 6, I will write the remaining. That is 66. Instead of writing 66, you can leave it, sir. Okay, in the remaining, we can write. Suppose this is my slots, 10 slots. So in all these, I will write 10 operations. In the remaining slots, I will write T2. Right? That's it. Right? So out of the total schedules, N1 plus N2, how many slots you need for T1, sir? You need N1. What is the value of it, sir? According to the formula, it will be N1 plus N2 factorial divided by N1 plus N2 minus N1 factorial into N1 factorial. So what is the answer, sir? N1 plus N2 factorial divided by, the first one is N2 factorial, the second one is N1 factorial. Instead of that one, to have some rhythm, okay, so to have some rhythm, you can write N1 plus N2 factorial divided by N1 factorial into N2 factorial, so that you can generalize for 3 transactions, 10 transactions, sir. That is my intention, but this is the logic behind it. Suppose I have 3 transactions, then what is the answer, sir? N1 plus N2 plus N3 factorial by N1 factorial, N2 factorial, N3 factorial. What is this N1, N2, N3 here? They are the number of operations in first transaction, second transaction, third transaction, respectively. Similarly, we are having K number of transactions. Then what is, sir? The same story, sir. This is the total number of possible schedules, sir. Out of these, some may be concurrent, some may be serial. Okay. Hope you know already the number of serial schedules. What is the number of serial schedules for this situation, sir? Number of serial schedules. That will be equal to n factorial. What is n, sir? Number of transactions. Here, how many transactions you are having? K. So it will be k factorial. Hope you understood it. Now, why you need to start 2 transactions at the same time? Why you are doing 2 or 3 works at the same time, sir? In generally, we also do, we will watch the TV and we will take breakfast. At the same time, we will operate mobile. Why to do 3 tasks at the same time, sir? The best answer is increase the disk utilization. That is, we are increasing the memory utilization or our caliber utilization. So we are utilizing the CPU in more effective way. And the best one is reduce average response time. Why people will do 2 or 3 works at the same time? They want to save the time. They want to save the time. So simply, instead of saying all these things, reduce time to complete all the works, or simply you can say to save the time, right? So these are the 2 advantages of concurrent execution. Now the question is, we have advantages. I can save, sir, no issue. Any problem? Something like I am watching TV and I am taking tiffin or I am taking some breakfast. Is there any problem, sir? Yes, of course. Whenever I am watching, I may not clearly observe some stones are there in my breakfast, right? So there is one possibility. So like this, we have some disadvantages or some problems whenever I do the transactions simultaneously or concurrently. Now, can we have the problems, or what is the list of problems we have in the case of transactions, not in the case of humans, TV, breakfast? What is the list of problems we can have in the case of transactions in DBMS? Let us see it. So the problems are the disadvantages with concurrent execution. The first one, last update. What is meant by it? Suppose I have 2 transactions. There is a data item XR. T1 wants to modify it, so he reads the value. Then before he do the second operation, T2 also reads the value. So both read the value of X. Then T1 modified the value. Then T2 modified the value immediately. Now the question is, let us assume the seconds. This is first second. This is second second. This is third second. This is fourth second. Now the question is, who used this modified value of X? Who used it? Who used this modified value of X? No one used it, right? Something like initially I have 100. It reads 100. It also reads 100. Now let us assume he wants to modify as 150. He modified to 150. Then immediately T2 comes and let us suppose he modified to 200. Now the question is, who used 150? No one, right? Then what is the use of updating it, sir? So what is the use of this operation? Even if you do it, it don't have any effect because some other people immediately using it. This is the problem of last update. Someone updated, but we are losing it without using it. Hope you understood it. The second one, dirty read. What is dirty read? Okay, simple, sir. Something like T1 reads a value and it writes a value. Before he commits, something like somewhere he is committing. That means till he says this right mark, he also don't know whether this value is correct or not. Or there may be a situation where he need to roll back or he need to restart. But suddenly T2 reads it. Because of this, that cascading rollbacks will occur. Right? Suppose if this fellow waits till here, then there is no problem. But this fellow is reading the value of X from T1, where T1 didn't give any confirmation for the value of X. T1 never says this is the correct value, please continue. When he will say, sir, at this point of time only he will say. So T2 is not waiting. That is the problem of dirty read. So we can simply say reading a uncommitted value. Reading a uncommitted value. Hope you understood. Dirty read, that's it. Then unrepeatable read. Unrepeatable read. What is meant by it? Suppose T1 is there, T2 is there. T1 reads the value. Okay. Then after some time or maybe somewhere else, T2 reads the value and modifies it. In this meanwhile, T1 may work on some different items. Now again you want to start the work on X. Again you want to start on X. Then for safe side you want to read it. Okay. Assume initially X value is 100. So here he taken the value of 100. Then T2 also taken the value of 100. Suppose he modified to 150. Whenever T1 is reading for second time, how much he is getting, sir? 150. So then he will have a dilemma, whether it is 100 or 150. Have I done anything wrong? Initially it was 150. That means whenever I am reading the value for first time, I got 100. Now this time I am getting 150. What happened? So that is unrepeatable read. Hope you understood it. Right? The next one. Phantom phenomenon. What does it mean? Phantom phenomenon. Okay. Something like in one round or in one round I will get n number of records. In another round, I may get either n minus 1 or n plus 1. It is not only plus 1 or minus 1, sir. It may be some other number, n minus some 10 or n minus n plus some 10. Okay. Let me give the best example. Suppose in a class you are counting the students. In a class you are counting the number of students. You started here 1, 2, 3, so on, like that you are continuing. So you are at this stage. When you are doing it, suddenly some 3 students entered and taken seats in second bench. So that means if I repeat the count, what will happen, sir? 3 will increase because some 3 students entered in the database. Or while you are counting, some students may left the class. Then some 3 students may decrease. That is phantom phenomenon. So in one round or in one transaction, I may get some n number of records. If I do the same thing, I may get some different number of records. That is phantom phenomenon. Incorrect summary. Phantom phenomenon, incorrect summary, both seems to be almost same, sir. Almost same. Okay. For example, suppose I have some 10 records in which I am calculating the total of X. Instead of X, let us consider age or some percentage. Let us consider the percentage and let us assume these are the students. You are taking some average instead of total. I think it will be nice if I consider average. You can take anything, sir, no issue. So I am considering average of percentages. So you calculated the first percentage, I mean, you got the first percentage, second percentage, and third percentage, and you are making the total and average. Suddenly, or at the same time, second student got revaluation result. Second student got some revaluation or some supply result. So his percentage may increase. That means again, if I repeat the average calculation, it will be some different value, right? So I can say like this: in round one, if I got some X summary, sir, summary means that may be average, total, count, anything. In round two, I don't get again X. I may get X plus or X minus. That is incorrect summary. Hope you understood it. The last one, blind rate. What is blind rate? Suppose T1 reads a value and he modifies a value. Something like I have 100. Okay. So T1 reads a value 100 and it modifies to 200. It modifies to 200. Okay. Now what the scenario is, T2 wants to make the value of X to 150. Makes the value of X to 150. So whenever he wants to make the value of X as 150, he don't mind what the initial value is. It may be any value, but he wants to fix the value of X to 150. So he don't read the value. Directly he modifies to 150. But it is already 200. So it may be decreased or increased, but he don't want to read it. So without reading, we are writing. Without reading, you are writing. Let me give the best example. Suppose I have a company in which I have so many employees. Now, suddenly I decided I want to give fixed salary for each and every employee. So what I do is, I will make 50,000 per month for every employee. Whatever the previous salary, I don't mind. That may be 10,000, that may be 1 lakh also. But now I want to fix 50,000 for everyone. Then do you need to read what is the previous salary, sir? No, right? Whatever it may be, what is the value you are going to write? You are going to write 50,000. Then why to read it, sir? You don't read it, right? So that is blind rate. So without looking at what the previous value, I am writing it. Is that clear, sir? Right. So let us do one previous question, sir. Consider the following database schedule with two transactions T1, T2. Fine. It is a schedule, sir. R2 of X. Sir, R2 of X. What is meant by it? Transaction 2 reading a value of X. Suppose I have R1 of X. Transaction 1 reading a value of X. Clear, sir? That is meant by it. Okay. That is what they given, sir. And there is one more, A1, A2. What is A1, sir? T1 aborted. That means it was killed it and it needs to be restart. So, okay, in our simple language, you can say you killed it. So it may be restarted. Similarly, A2 also. Now the question is, which of the following is correct? S is non-recoverable. S is recoverable but having a cascade abort. S does not have a cascading abort. S is strict. Sir, for all these things, if I have two transactions, if this depends on T1, then which one committed first, or is T2 started before commits? That is the story. Now look at this. T2 reads the value of X, then T1 reads the value of X. I think better to write like this. T1 reads the value of X, then T2 reads the value of Y, then T1 reads the value of, it's not read, right? It's write. 1 minute, sir, let me write it. What is the first operation, sir? T2 reads X. Then second operation is T1 reads. Third operation T2 reads Y. Fourth operation T1 writes X. Fifth operation T1 reads Y. Sixth operation it reads X. Now the question is, who is depending on whom? Please observe it, sir. T2 reading a value which was modified by T1. T2 reads a value which is modified by T1. That means T2 depends on T1. Then if I should not have cascading rollbacks, that is a minimum thing. If I should not have cascading rollbacks, T2 should wait till T1 commits. That means first T1 should commit, then T2 should commit. Here there is no commit, sir. Okay. So what will happen, sir? Whenever T1 restarts, T2 also should restart. T2 also should restart. Am I clear, sir? But there is no problem that there is no information about commits. Simply T2 is depending on T1. Okay. T2 is depending on T1. Instead of this one, okay, if they given some commits, then you can give clarity whether it is cascading rollback or not. But since they are not given any information about commit, I cannot decide whether it is a cascading rollback or strict schedule and anything. The only information we can give is it is recoverable. It is recoverable. Why, sir? Whenever T2 restarted, whenever T1 is restarted, something like it is restarted. Here you restarted, right? Then T2 also having a possibility. He can also restart. Am I right, sir? So it is recoverable. We don't have any other information. So where it is, sir? It is recoverable and but has a cascading abort. Why cascading abort, sir? Since T1 restarts, something like he striked out and again he is restarting, then automatically T2 also looks, oh, something might happen wrong. Again, let us restart. So S is recoverable, but is having a cascading abort. Am I clear, sir? So that is about concurrency or the types of schedules. In the next class, we will discuss about what is serializable schedules. Thank you.